Scott, first of all, I just wanted to thank you so much for taking time out of your very busy schedule to talk with me today. I am super excited to do an employee spotlight with you based on your current work that you do for SSAI. My first question I wanted to ask you was, what drew you to SSAI and how does the company's mission resonate with you personally?
Yeah, thanks, Jason. Yeah, happy to take time out of my schedule to chat about this stuff. So, yeah, what drew me to SSAI was the ability to work with the customer and work at NASA, really. SSAI's mission, I think, resonate with me because I like applying my knowledge, what I've learned in the past, my expertise to solve challenges in science and engineering. I've always been sort of driven by a curiosity to know more. That's kind of what led me from point A to B along my career path. I mean, I'm an engineer now, but I've been trained as a scientist. My PhD is in the science, chemistry specifically. So when I saw that I could, an opportunity to apply my expertise to sort of help the world, humanity, know more about the universe, understand our world better and find ways to make it, a better place, I said, yeah, I'll take that challenge. And honestly, it's like, I think me and a lot of people my generation kind of grew up with these popularizers of science. We got Bill Nye, Carl Sagan, people who really had these sort of ideological motives to doing what NASA does. I think kind of resonated with me all throughout my career. And as a kid, I dreamed of doing something like working for NASA. And then as I got kind of lost in my PhD, I never thought about it being possible. Then after my postdoc, I saw this and I was like, oh, I can kind of get back into that. And I used to want to be an astrophysicist, actually. And I just kind of, found my way into chemistry. So I'm happy to be here at NASA, happy to be working for SSAI. I like solving problems. I do that in and outside of work. I like puzzles, board games. I do rock climbing, which is like problems on a wall. So if I can solve problems at NASA and help the world, then, that's all for me.
Wow, that's awesome, Scott. And I really appreciate you diving deeper in terms of what drew you to SSAI, because I know, just like you said, I dreamed of working at a organization that supports global organizations like NASA, NOAA, and the U.S. Department of Agriculture, and many other global organizations. So the fact that I'm here as well, it definitely wasn't easy to get from point A to point B, but you definitely learned throughout the journey, and I'm just thrilled and honored to be here myself. And when you mentioned about Bill Nye, I'm sure you probably know the Bill Nye song, right?
Oh yeah, the theme song to the start of the shows.
Oh yeah, yeah,
Yeah,
Bill
yeah.
Nye, the science guy.
Bill, 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 Bill. Yeah. Yeah,
So
yeah. I love the consider the following. It was always good bits and stuff. Yeah.
uh, absolutely. Well, and it's great too that you like to solve problems. I definitely do too, because at SSAI you can definitely be challenged for sure. So I really appreciate you diving deeper into that. My next question I wanted to ask you was, you mentioned a little bit about your background and what inspired you to pursue engineering, and how do your projects like the multifunctional nanosensor platform, also known as MNP, and the Network for Assessment of Methane Activity in Space and Terrestrial Environments, also known as NAMASTE, contribute to solving real-world challenges?
Yeah. So I guess the first question of what inspired me to pursue engineering. Yeah, as I said before, I'm a scientist by training, but I also, I learned a lot of engineering along the way too. Maintaining instruments, glove boxes, spectrometers and stuff. And I like precision. And maybe it's just like a little perfectionism in me that I like making sure things are exact, precise. I'm also an analytical chemist, which is all about, thinking about error and measurements. And so in that sense, that's kind of like what led me down to an engineering path, I think. So how do the projects like MNP and Namaste contribute to real world problems? So yeah, I guess MNP is sort of I'll give a little spiel here. So MNP, which was designed by the PI Mamuda, is a platform in which it's versatile, that you can kind of change out components really quickly, and have a multifunctional sensor for chemical sensing, pressure sensing, temperature sensing, all the above. And the MNP is actually in the Namaste sort of project, in the sense that it is the functional aspect of it. The Namaste is just the idea of having autonomous, multiple sensors coordinating in an environment. And the way that it solves real world problems is that, well, it's a lot of planetary problems. So you can think about Namaste specifically, both in the context of Earth and Mars. So Namaste allows us to kind of get a better, more accurate spatial map, using like drones. So instead of using satellites over a larger area, you can think about, in this sort of swamp out in Alaska, which is where we do our field work, what is the precise location of methane? Is it over there, or is it over there, and why is it over there? What's the dissipation of methane look like as it goes up? So you get more spatial resolution that way. And we're doing this on Earth right now, because if you could prove that sort of technology, if you could demonstrate that technology in Earth, then you could apply it to something like Mars. If you weren't aware, but Mars, there was a methane signal found on one of the Mars rovers, or methane was found somewhere on Mars, and it really baffled a lot of scientists. Like, well, where did this come from? There are natural sources of methane, but they're not. We're not sure if that's there. Is that natural, or is it life? And so, finding the source of that methane on Mars could be a very intriguing, can answer a lot of intriguing questions. And so, if we can have multiple drones or multiple rovers on Mars coordinating and trying to get sort of this spatial resolution of where's this methane coming from, how much is there, can answer a lot of questions. And so not just yet geological, but potentially biological questions. So so those are a lot of the real world challenges that Namaste and MNP sort of contribute to, is not just problems on Earth in terms of how do we understand our world and mitigate problems that are causing billions of dollars in damage, such as wildfires and stuff. But it also answers more fundamental questions, like what's the geology on Mars like? What causes methane to come up? Is there methane on Mars? Does that come from small cells in the soil deep down? And so there's a lot of applications of this, beyond just what I just mentioned too. So I can just ramble about the things it can contribute to, but so that's how I think of it, at least.
Wow, that's very fascinating, Scott, and I appreciate you breaking down in terms of what MNP and NAMASTE, does, and how it best contributes more to our understanding, of Earth and also of other planets. And I didn't realize that on Mars that scientists found some methane there. And was that like earlier this year, or just out of curiosity?
I don't want to answer with confidence, because I don't know the full story. I just talked to the planetary scientists. I know that at some point, like, a small blip of methane was found in one of the mass specs, and I know there's a debate going on as to whether it was a real signal, how much was there, if it was a real signal, and then the question of where did it come from, because as I said, methane, once it kind of gets up into an atmosphere, solar winds can kind of rip apart methane and decompose it. So if methane's chilling around for a bit in a appreciable quantity, then that might hint to some interesting phenomena going on down on the surface. So like I said, I'm not going to say with confidence about the story of methane on Mars, because I am still learning it. But I think it was pretty recently announced that there was a small signal for methane found. Maybe in the past couple of years.
Oh. Interesting. Well, that's very fascinating, and we definitely look forward to hearing more, insights, and look forward to teams gathering more data just about it as well. So I'm very, very excited to learn more about that. And Scott, like I said, I really appreciate you diving deeper and explaining more about your projects and how they contribute to solving real-world challenges. It's just absolutely incredible. My final question I wanted to ask you was, and this is a fun question as a side note, but the question is, if you could design an engineering project for a sci-fi movie, what would it be and how exactly would it work?
That is an interesting question. And how would it work is an even harder question to answer. I would have to give this more thought, really. I guess if I were to just think about, so yeah, I am a huge sci-fi nerd. I'll start with that. I don't know if you remember seeing me up close in the gala event, but I did have a little Star Trek tie clamp. So and yeah, I nerded out a bit with some people around there about Star Trek and my favorite series and stuff. But I think actually what I would have to stick with as far as the sci-fi genre might be right now just Dune, because after the movie came out last year, I got heavy into the books because a lot of interesting philosophical sort of questions presented in the books, which really drew me to it. So I'm really into the Dune kind of. I got a real Dune kick going on right now. So if I had to choose an engineering project, it'd probably be something in Dune.
Okay.
And what would it be and how would it work? Honestly, maybe I would like to work on something with the way that some the vehicles and technology in Dune operates. There's this concept called I think it's called the Helmholtz effect or something. And it's basically like the idea behind it is some cyborg android person thousands of years ago determined a way to like levitate ships and like defy gravity, but also like shield lasers and do all this crazy stuff. And so it's this sort of like broad theory that has a lot of applications, including things like flight. How do you get from point A to B in the universe so quickly, and how do you navigate that sort of space time in a fast way? And something like that would be really cool. I've always been interested in space flight. As I said, Star Trek, Star Wars. There's hyperspace and warp drive and all that stuff. So if I could work on something like that, that would be cool. But I guess if how would it work in terms of my project, maybe it would be more of a fundamental project studying more applications of this Helmholtz effect. And I hope I'm saying it right. I might be misremembering it. But yeah, just studying more applications for that would be cool, because that's just the theory behind that. If as they lay it out in the books, could be widely applicable to a lot of different sciences and fields and stuff, and not just for space travel and military defense and stuff. So it'd be cool to work on that, understand it, and try to find new ways to apply that.
Wow, Scott, that just sounds absolutely fascinating and incredible. There definitely is a possibility to work on that, and it's great to hear your thoughts in relation to that, and that you are very into sci-fi as well. I definitely am into sci-fi myself as well. So, but that's definitely something very cool that can certainly be worked on in the future. So it's definitely awesome to hear your thoughts there on that. Scott, with that, again, I just wanted to thank you so much again for taking time out of your very busy schedule to talk with me today and do an employee spotlight based on your work that you do at SSAI. Your work is truly phenomenal, and you are really making an impact and a difference globally. And everybody around the world is going to continue to be fascinated by the great work that you are doing. Please definitely keep us informed in terms of continued insights and future data that you get with your work, and we cannot wait to highlight it.
Yeah, no, I'm very happy to chat about it, and happy to chat about it more sometime. And thanks for highlighting the work. You know, and it's not just me, but the team I work on are all amazing people that I learn from every day, and help make these sort of projects go forward. So yeah, happy to chat anytime.
Absolutely. Well, as you mentioned, teamwork is very important. So you bring up an excellent point. When you have a great team and you have a great vision, it can definitely make all the difference. So that's an awesome point. So thank you again, Scott, for your time today.
Of course.